Good morning, guys. Today we're going to see one of the programs with respect to pointers. So this is a program to find the sum, mean, and standard deviation of all elements in an array using the concepts of pointers. That means you need to find the sum of an array and calculate mean of the elements in an array and standard deviations of an array elements. So in this case, we will just recall few formulas which you have studied in school days regarding mean and standard deviation. So let us just have a recall of these formulas. So if you can see here in the left hand side, there is an image which contains a formula to find out standard deviation. So before finding out the standard deviation, there are certain things we need to find out in this program. So basically, first the thing what you need to find out is sum of an elements, okay, of an array, but using pointers. So let us consider an array A, which contains 5 elements, and that 5 elements can be any order. It need not be in ascending or descending order. It can be in random order. But in this case, I have taken an example which is in an order. So we have a set of 5 elements, that is 10, 20, 30, 40, 50, stored in an array called as A. So basically we need to find out sum of these elements. So sum of these elements is add all the elements in an array, that is 10 plus 20 plus 30 plus 40 plus 50, which is equal to 150. This is the first thing what we need to do in our program, that is add all the elements in an array. Already you have seen how to add an elements in an array using a for loop. But here there is a slight change, that we are not going to add up them directly. We are going to use the concepts of pointers and add them out. And next, what we are going to do is, so once the sum has been found, the next thing what we need to find out is mean of all the elements in an array. So you might have known how to calculate mean. Mean is given by the formula, the sum of all elements divided by the number of elements. So sum of all the elements here is 150, and 150 is sum and divided by n. N says number of elements in an array. How many elements do you have in an array? That is 5 elements. So when you divide 150 by 5, you get the mean. So the mean is 30. Okay, so that is how we find out the mean. So once we get the mean, then we can calculate the next component, that is standard deviation. So how to find out standard deviation? So look at the formula. Standard deviation is given by a formula, summation of x minus mean whole square divided by number of elements. So the standard deviation formula says that it's a square root of, so you have a numerator and denominator. In numerator, what you need to do is you need to find out the summation of each element minus the mean whole square. You need to add this particular for all the elements. That means each time the x will be varying. So if you can see this particular expansion, so the first element is in an array is 10. Okay, so x here denotes 10. Okay, so 10 minus mean. What is your mean value? Mean value is 30. So 10 minus 30 whole square plus the next element. So it's a summation of all the elements. Okay, 20. So the next element is 20. 20 minus mean whole square. Okay, 20 minus 30 whole square. Then the next element is 30. 30 minus 30 whole square. Plus next element is 40. Then 40 minus 30 whole square. The next element is 50. 50 minus 30 whole square. So you need to find out the summation of all elements minus the mean whole square. Okay, so that will get you the numerator. So when we calculate this, we get the numerator as 1000. Okay, and this is not standard deviation, just we calculated the numerator and it is divided by n. So you can see that this will be, this 1000 is saved in a variable called as sum of standard deviation. Okay, we have just found the sum of this, summation of this. Okay, so summation of this is stored in sum of standard deviation, that is 1000. Okay, sum of standard deviation divided by n. So that is what is the formula. New denominator is n. What is n? N denotes the size of the set. That means how many elements do you have in an array? That is 5. So 1000 divided by 5. If you find out the square root of this particular formula, you will get the standard deviation. So 1000 divided by 5 is 200 and square root of 200 is 14.142. Okay, so this is how we find the sum, mean and standard deviation. So to find out the sum, you just have to add up all the elements in your array, and to find out the mean, so the summation of all the elements in an array divided by number of elements will give you mean. And how to find out standard deviation? Standard deviation is given by the formula square root of summation of individual elements minus mean whole square divided by n. So first we need to find out the numerator. Numerator has been stored in a variable called as summation standard deviation. That is nothing but each individual element minus mean whole square. You need to sum it up. Okay, and that summation should be divided by n, and its value should be found the square root. So if you find the square root of that, you get the standard deviation. So this is what is the basic formula for this particular program. So now let us go back to the program. So first, as you all know, we require some variables to do this particular thing. So first we have taken an array. As you know, that array name was A in the program. So we have taken an array of size 10. That means it can store at most 10 elements in it. And then as I said that all these operations, what we are going to perform, it's going to be performed using the concepts of pointers. Okay. So first the pointers has been declared, and since the pointer is going to point the array elements, so let us just go back to this particular term. Okay, so when it comes to an array elements, so carefully observe, each index will have an address to it. Okay, so there is an address for 0th index, there is an address for first index, there is an address for second index, and so on. So now let us just go back to the program. So first we have declared an array of size name A and of size 10, and we have declared a pointer which is going to point that particular array element. So since array is a floating point, we have declared a pointer is also of floating point. Okay, even though we are entering the numbers in decimal format, it can also have numbers in floating point value. Okay, so then we require a variable to find out mean. Okay, mean, which since it's a division, sum divided by n, since it's a division, so there is a possibility that it might come a floating point number. So mean is also declared as float, and then we need to find out standard deviation, and then we need to find sum. Okay, and we require some std. First we need to calculate the numerator. Okay, so some std, these are the variables which has been declared. And to control the for loop, we require two integer variable n and I. Okay, n stands for number of elements and I looks for the number of iteration. Okay, so it has to go from one index to another index, so that will be traced by I. So first, user has been asked to enter the number of elements. That means in this particular example, how many elements you need to enter? You need to enter elements, 5 elements, that is index from 0 to 4. So if you can see this particular for loop, this is going to enter the array elements from, so n is going to store the value as 5, and then we need to enter elements one by one. So we have to use a for loop. Okay, so in the for loop, if you can see, we have a scanf statement because it asks user to enter 10, 20, 30, 40, 50, and each index where it will be stored is from 0 to 4. So you can see that the loop is starting from 0 and it is not going up to n, it is going just less than n. That means less than 5. Less than 5 means it will go up to 4. Okay, and all the elements is stored in array A. So first I value will be 0. So it will be storing 10 in A of 0, and the next enter element, that is 20, will be stored in, because I value will be 0, then it will be incremented, then it will become 1. So the next index it will be storing in A of 1. The next elements where it will be storing is A of 2. So on, it will be storing all the elements till A of 4. So once it has been done, what happens is, now carefully observe, after the elements are entered into an array, we are bringing our pointer concept here. So if you can see what we are saying, PTR is equal to A. That means what is A? A is an array, and we are assigning that array to the pointer. So whenever you call an array by its name, this will be, so you know that pointer is a variable which stores the address of another variable. So what it is going to store is a, whenever you call an a as an array name, it will store the starting address of a. That means, so 1 second, let me just have a address to this index also. So I want you to just wait for a while. Okay. So look at this particular example. Here what happens is every index has an address. So 2000 is an address of 0th index. And since, okay, sorry, because it's an 8 bytes address. Okay. So next thing is 2016. And next you have 2020. Sorry, not 2020, 2024. And next you have 2032. Why there is an 8 bytes gap for each address is because our a is of type float. So float takes 8 bytes. Okay, so each location is of 8 bytes size. Okay, so now, and as an array definition says that it stores the address in continuous memory location. Okay, now what happens is once the element has been stored, what we are doing is we are storing array A in a pointer. So when we assign an array to a pointer, it stores address of A in pointer. So what is address of A? A contains so many addresses. Okay, so address of A means the address of A will be the starting address. So even though it has 5 addresses, whenever you call an array by its name, the base address, which is the starting address, will be stored in pointer. So that means what is the value of pointer now? PTR. PTR starting address of A is 2000. So PTR is pointing to 2000. Okay, now let us find out the sum of n elements using that PTR. That means we are going to add 10, 20, 30, 40, 50 using the address, starting address. Okay, so we are going to move from one address to another address using the pointers. So let us see. Now what happens is when you assign A to pointer, the starting address of A will be stored in PTR. So now PTR is pointing to 2000 because the starting address of A is 2000. Okay. And now let us see how does it calculate sum. So as you know, the sum means we should add each and every individual elements, 10 plus 20 plus 30 plus 40 plus 50. This is how what we need to add. So let us see how we are going to do this using the concept of pointer. Now carefully observe the loop, because we have 5 elements, so the loop has to run from 0 to 4. So I is equal to 0. So once this loop completes, when it gets to the 4th index, the loop will get terminated. So let us see one by one. So now initially I will be pointing to 0. Okay, initially the I value is 0. So this is for reference. So sum is equal to sum plus star PTR. So let us see what is it. Sum is equal to initial value of sum. What is the initial value of sum? It is 0. Okay, 0 plus star. So you know what is the meaning of star. Star means value at operator. It means value at operator. So what is the initial value of PTR now? So PTR is pointing to 2000. So 2000. Okay, so this means star of 2000 means value at 2000 address. That means what is the value in the address 2000? So what is the value in the address 2000? It is 10. So this entire star of 2000 will be replaced by 10. So what is 0 plus 10? 0 plus 10 is 10. And where it is stored? Right now 10 is stored in sum. Okay. Then what we do is we need to move. We have calculated the first element. Now this 10 has to be added with 20. That means the pointer which was pointing to 2000 has to move to 2008. So if you recall the concept of pointer arithmetics, what we have done, when we increment a pointer, that means pointer plus plus, it's not going to just add 1 to it. If it would have been a normal variable, it would have added 1. So when you do this, what happens is PTR plus plus will do PTR plus 1 into size of PTR. Okay, so this is how it does. PTR plus plus will do PTR is equal to PTR plus 1 into size of PTR. So let us see. This will get expanded in this format. This will get expanded in this format. So what happens with this? Let us see. So when you do this, what happens is for PTR, it will be PTR is equal to, what is the initial value of PTR? Now it is 2000. So it will be 2000 plus 1 into size of PTR. So what is size of PTR? So PTR is of what type? It's of float type. So what is the size of float? 8. So it will do 2000 plus 1 into 8. The reason why it is 8, because size of PTR means PTR is of type float. So size of PTR is 8. So 2000 plus 1 into 8 will be 2008. Okay. So what is 2008? Now after doing PTR plus plus, the value of PTR has been changed to 2008. That means if you carefully observe, from 2000 we have moved to 2008. Okay. So now what is the value of PTR? 2008. Okay. So let me comment this statements. Okay. These are all comments. Okay. So these are not part of the program. Okay, for your reference, I am just expanding it. Now what is the value of PTR? 2008. Now I value was 0. When it becomes I plus plus, now it has moved to first element. Okay, now again what we are doing, sum is equal to sum plus star PTR. Okay, so what is the current value of sum? Current value of sum is 10. Okay, because we have calculated 10. Now right now sum is equal to sum value is 10. 10 plus star, what is your PTR? What is the current value of PTR? Current value of PTR is 2008. As we recall, star of 2008 means it's not going to add 10 to 2008. It is going to add 10 to value at 2008. So what do you have a value at 2008? The value at 2008 is 20. So this will be replaced by 20. So that means we have added first two numbers. So when we had first two number, it will be 10 plus 20. So what is 10 plus 20? So 10 plus 20 is 30. Okay. So now the current value of sum is 30. After calculating the sum, then again we increment PTR because we added this 10 and 20. Right now it's in 2008. Now it has to go to 2016. So carefully observe what happens. We are doing PTR plus plus. PTR plus plus means PTR is equal to PTR. What is the current value of PTR? 2008 plus, when you do PTR plus plus, this is what happens. So you need to just write PTR plus plus. Internally, it will get expanded in this formula. Okay, so PTR 2008 plus 1 into size of PTR. What is size of PTR? PTR is of what type? Float. So what is the floating point size? It is 8. So what is 1 into 8? 1 into 8 is 8. 2008 plus 8 is, so it will become 2016. Now the pointer has moved to 2016. Now we are pointing to 30. So again the loop will run. Loop will run becomes, it becomes I is equal to 2. Okay. Now we find out sum is equal to sum plus, what is the current sum? 30 plus star of its PTR. What is the current value of PTR? It is 2016. So value at 2016. So what is value at 2016? Value at 2016 is 30. So 30 gets, so this will become 30 plus 30. What is 30 plus 30? 30 plus 30 is 60. So sum becomes 60 now. Now again, we found the 10 plus 20 plus 30. Now, since pointer is pointing 2016, it has to be moved to 2024. The same thing, PTR plus plus. So what is current PTR? Current PTR is 2016 plus 1 into size of PTR. What is size of PTR? It is 8 because it's float. 1 into 8 is 8. 2016 plus 8 is 2024. Okay. So you can see now PTR has been moved to the next element, that is 40. Now again loop runs. Loop runs I is equal to 3. Okay. Now what is the current sum? Current sum is 60. 60 plus star. Star. What is the current PTR? 2024. So this will be 2024. So what is value at 2024? Value at 2024 is 40. So this will be replaced by 40. So what is 60 plus 40? 60 plus 40 is 100. Now sum is pointing to 100. Okay. Then again PTR plus plus, because now we have found the 40th, so added 40 to the previous sum. Now we have to add 50. If we have to add 50, the pointer has to move to 2032. So for that, again increment PTR plus plus. You need to write just PTR plus plus. When you do pointer arithmetic, internally pointer arithmetic will be in this fashion. So what is current PTR? Current PTR is 2024. Okay, plus 1 into size of PTR. What is size of PTR? Since PTR is 8 bytes, it will be 1 into 8. So what is 4 plus 8? It is 2032. So again we come here, I will be incremented. I will be 4 now. Sum is equal to sum. What is the current sum? 100. 100 plus star of, what is PTR? PTR is now 2032. So it will be star of 2032. So when you do value at 2032, what is the value at 2032? It is 50. Okay, value at 2032 is 50. So now it will write 100 plus 50. So what is 100 plus 50? It is 150. Okay, so then again PTR plus plus. It will do PTR plus plus, but there is no value. Okay, you need not worry. PTR will be moved. Okay, same way. 2032 plus 1 into 8, 2040. Okay, but we are not going to calculate sum because there is no element, because I value is 4. Okay, now I value will become I plus plus, that is 5. But when you increment this to 5, what will be this condition? 5 less than 5. N value is 5. Is it 5 less than 5? No, it is false. So it will never enter into the loop. Okay. So again, we found sum. What was supposed to be the sum? Sum was supposed to be 150. We found sum. Now what are we supposed to find? Mean. Mean is given by sum divided by 1. Already we have 150 in sum. Okay. So look at here. Mean is equal to sum. What is sum? 150. 150 divided by 5. Okay. And that is equal to 30. Okay. So we found, once we have found mean, what are we supposed to find out next? We are supposed to find out standard deviation. So standard deviation is given by this formula, that is square root of summation of x minus mean whole square divided by n. Okay. So we have to do this in two ways. First, we need to find out numerator and then denominator. So first, let us find out numerator. Okay. So carefully observe here. Again, PTR is equal to A. But what was PTR pointing to? 2040. Okay. So when you see this formula, when you need to find out the numerator, we need to start from first number, that is 10. Okay. 10 is in which address? 2000 address. Already the address has moved to 2040. Do you have 2040 here? No, it has crossed the array elements. So we need to bring the array back to pointer back to the starting address. How do you bring a pointer back to the starting address? As I said, if you just assign the array name with a pointer, pointer will point to the starting address. Okay. So now where is PTR? This is gone. PTR equal to 2040 is been removed because now the current value of PTR is assigned to A. What is A's starting address? 2000. So now again PTR is being pointed to 2000. The reason why PTR was made to point to 2000 is because now we need to find out sum of standard deviation, that is x. X is the first element, 10. The reason why we need to allocate starting address to pointer is because we need to find 10 minus 30, then 20 minus 30, one by one, like how we found sum. Okay. Now you can see again we remove the same for loop, like how we found sum the same way, but the only changes here is the formula. So the formula, what is the starting sum is 0. Sum of standard deviation is 0. So let me just summarize this. Is equal to 0. Sum of standard deviation is equal to 0. Power of star PTR. Okay. What is the current value of PTR? 2000. So star of 2000. So star of 2000 minus, what is your mean? Your mean is 30. Okay, 150. So 30. Okay, power of star of comma 2. Okay, we'll see what is the 2 and what is this power operator. So as you all know, it's power operator. So this is your base. First parameter is your base and second parameter is your exponent. Okay, so look at here, star of 2000. So what is star means? Value at 2000. So what is value at 2000? 10. Okay, so you can see it will calculate, replace star of 2000 by 10. So it is calculating 10 minus 30 whole square. It is power. So what is your base? It is 10 minus 30. So if you can see this formula, what is the first thing you need to calculate? 10 minus 30. This is your base. And what is 2? 2 is your exponent. That is what is happening. So it calculates 10 minus 30 whole square and save it in sum std. Okay, so right now sum std is what? 10 minus 30 whole square. Okay, again we need to increment ptr plus plus. As I said here, ptr plus plus. So whenever you do ptr plus plus, what happens? It will be expanded in this form, in this basis. So it get expanded in this basis. Okay, so what is ptr is equal to ptr? So it get expanded with ptr is equal to ptr plus 1 into size of ptr. Okay, because we have done ptr plus plus. So as I said, we have calculated 10 minus 30 square. Next, what you need to calculate? That should be added with 20 minus 30 whole square. Where is your 20? 20 is not in the same address. It's in the next address, that is in 2008. If you want to move to the next address, we need to simply increment it. When you increment it, look at what happens internally. Like how we found the sum, it's the same way it happens. So you can see equal to, okay, what is the current PTR? Current PTR is 2000. Okay, so we just add 2000 plus 1 into, what is size of PTR? 8. Okay, so 2000 plus 2000, 1 into 8 is, it gets replaced by 2008. So now what is the current PTR? Current PTR is equal to 2008. So again it goes to this, I value will was 0. Now I value will become 1. Okay, because it's incremental. 0 will be incremented to I plus plus 1. 1 is less than 5, it is true. So it will come again into the loop. First, now what is the current sum standard deviation? Current sum standard deviation is this, that is power of 10 minus 30 whole square. Okay, for this, that is the current sum. Okay, for this plus again power of star of, what is the current PTR? Current PTR is 2008. So it will be 2008 minus, what is the mean? Mean is 30, comma 2, that is whole square. Okay. So now, if you can see, what is 2008? Value at 2008. Okay, what is value at 2008? It is 20. So this will be replaced by 20. Okay, so what is the current sum standard deviation? It is a sum of this two. Okay, so similarly, each time when the loop runs, this pointer will keep on. Now the pointer will be again pointer plus plus. When you do pointer plus plus, for this, it will be adding another 8. So that will be 2016. Okay, so 2016, what is value at 2016? It is 30. So similarly, this will find out the sum of standard deviation. For this, that means for this, an extra power will get added. That means for this will be plus. Instead of value at 2016, it will be 30. Okay, so it will be adding up in this way. So in this way, this keep on going until this happens. That means until this particular thing happens, it calculates entire thing. So once the loop terminates, it would have calculated your numerator. That will be stored in sum standard deviation. What is the numerator? What is the answer for this sum standard deviation? It will be 1000. So once it has been done, okay, so what will be saved in once this loop has been completed, this variable will going to store what? Entire this. Okay, that's your numerator. In this formula, that is your numerator. So what is the answer for it? It will be 1000. So what will be in some standard deviation? It will be 1000. That is not standard deviation. Standard deviation is what? We have just calculated the numerator and should be divided by n. Okay. So you can see that what is n? N is 5. So we calculated some standard deviation. It is 1000 divided by n is 5 and it is square root of this. Okay. It is square root of this. Square root of this will give you standard deviation. Okay. Once the standard deviation is completed, our program says that we need to print sum. Already you know what is there in sum. So look at it. We need to print this variable which was carrying 150. So you can see that printf sum is equal to percentage f sum. Okay. Next, once the sum has been calculated, next what we calculated was mean. So we need to print mean is equal to, and finally, the last thing what we calculated was standard deviation. Where is standard deviation? It is there in this variable. Don't confuse it with some standard summation of standard deviation. We calculated summation of standard deviation just to find out the numerator, but it is square root of numerator divided by n. So where is the numerator? Some standard deviation divided by n. Square root of it will give you standard deviation. So we printed finally standard deviation. So that is what? Nothing but square root of 1000 divided by 5. What is 1000 divided by 5? It's 200. Square root of 200 is 14.142. Okay. So now if you can see the program, let us see, are we going to get sum as 150, mean as 30 and standard deviation as 14.142 for these elements by running this particular program. Okay. Let me share you the compiler. Okay, so let me run this program. It's the same program what you have seen. So let us just run the program, and now you can see the output of this program. I hope so. You are seeing this window, which is going to show you the output. How many elements? 5 elements. Well, which are the elements? 10, 20, 30, 40, 50. So what is the sum? Sum is 150, main is 30, and standard deviation is 14.142. So look at here. Sum is, okay, sorry, I didn't run this program. Let me first compile this program properly. Let me go to this program again. Okay, I think, okay. So let me compile this first. One second, guys. So let me build this program. So you can see that there is 0 errors in this program. Okay. Now let me run this program. Okay. So I hope so you are seeing the output window. 5 elements, 10, 20, 30, 40, 50. And now you can see that how much is sum? 150. What is the mean? 30. And standard deviation is 14.142. Okay. So all these are floating point. You are getting the decimal also. Okay. So this is what is the program to find the sum, mean, and standard deviation using what concept? Using pointer concept. I hope so you have understood this program. Okay, so just go through this program, trace it one by one. It will be a very easiest program for you people to handle it using the concepts of pointers. So this is your lab program 2. Okay, thank you.